This video will be for vertex form, which corresponds, if you turn to page 6, about halfway down when you're going to see this box on vertex form. This is where our transformation rules from first semester can come in pretty handy, right? Well, remember this H is on the inside. This H is on the inside, and remember inside, back from that particular unit, was horizontal and backwards, right? Remember, we always moved the opposite way of what we thought. And we can see that K is on the outside, and we always saw outside as a vertical move, and there was no trickiness to that. It was kind of right where we started. So in other words, we're going to take our parabola and we're going to translate it. Since H is on the inside, it's going to be to the left or right a certain number of units, and K, since it's on the outside, right, there's our K, it's on the outside, that's going to be up or down. So to find the vertex, that's what vertex form is really, really good about. If you go back and you remember again, standard form was awesome. Like that C value, we could find the y-intercept very, very quickly. But the vertex required us a little bit more work. Now all of a sudden we're looking at what's called vertex form. The vertex is going to be very, very easy to spot. And what you're going to do is actually going to be opposite H, comma, K. So for example, before I'm filling the rest of that box, if you see here, these two, number 5 and number 6, are both in vertex form. Here's the H, here's the K. So we want opposite H. So what's the opposite of positive 1? Negative 1. And then you just copy down the vertical transformation for the K. So the vertex is the point -1, -2. Here, do the opposite of what's inside. So the opposite of -1 is positive 1. And then you go up 5. Understand the axis of symmetry must always go through, right? It passes through the vertex. It passes through the x part of the vertex. So the axis of symmetry is going to be very easy to spot. It's just going to be whatever the opposite of H is. So right, we have the vertex -1, -2 for this particular graph. Well, that means the axis of symmetry must go right through the middle of this. Here in number 6, the vertex is 1, 1, 2, 3, 4, 5. And we know the axis of symmetry must go right through the middle of this, right? And then the graph is going to open up if A is positive, and it's going to open down if A is negative. Those are pretty straightforward. So we look at number 5. There is no number in front, which means really there's a positive 1 in there, which means this is going to open up. You see the -1/3. This will open down. Fill in the axis of symmetry information, right? So what is that red dotted line? Well, that's the line x equals -1 in number 5, and x equals +1 in number 6. Now here's the issue. To draw these parabolas, we need 3 points. We've only got 1 in both of these graphs. So what we need to go ahead and consider is we need to think about what is the y-intercept. And it's not in the box, but when we did y-intercept with standard form, we just went straight for C. Well, the y-intercept here, you're going to plug x equals 0 into the equation and then solve. So if we do that, right, we're going to plug, so here's our equation, right? We have x plus 1 squared minus 2. So what we're going to do here, guys, is we're going to take that x, erase x, and we're going to plug in 0. So for the y-intercept, we're going to plug in 0. And just go ahead and work your way through that thing and solve it. You could plug this straight into the calculator, just put parentheses in the right place. You could kind of do it by hand if it's easier for you by hand. So this will turn into 1 squared minus 2. That's 1 minus 2, which is -1. So the y-intercept is -1. Go ahead and put a point on -1. And since we know the axis of symmetry, we can flip over that, and we end up with our third point. We connect it. It's a parabola that opens up. Here, -1/3, x minus 1 squared plus 5, right? So to find the y-intercept, what are we going to do? We're going to plug in 0 for x. So plug in 0 for x. This might be one that you feel a little bit more comfortable putting in the calculator. So what you could type in, do parentheses, -1/3, and then type this into the calculator. And what it's going to give you is 4.67. It's okay that it's a decimal, so just go up 4 and a little bit more, and it's sitting about right there. And use your axis of symmetry, right? We just need the same point on the other side, the same distance away, maybe about right there. When I connect them, it opens down, which again, right, at the very beginning of this problem, we said that does need to open down. So there's your quick look at how to use vertex form.